Hi folks! Welcome to Raymond's bite-sized tips. The theme for this tip is Sybase ASE. It is about a user-defined function for adding 1,000 separators to integer values. Some database accessing graphical user interface clients add 1,000 separators to the columns that contain integer and/or fractional numerical results. Others actively remove them, as the tip in the next video will show. It is not always possible to use a GUI for accessing a database. For example, reports run by a scheduled batch using a shell scripting language and a database command line interface. If there are very large numbers in the results, it can be difficult to make sense of them as they have been output. To make them easier to interpret, I created an ASE user-defined function for integer results to add 1,000 separators to them. The UDF is sprpm_str sepint. It is created like this. The input value can be up to 38 digits in length, and it is given in the first parameter at val. If the value does have 38 digits, there will be 12 of the 1,000 separators. With catering for a negative value, the result can be up to 51 characters long. The 1,000 separator is comma. If a different separator is required, one change to the local variable at sep, on line 100 of the source file, is all that is needed. The length to use for the result is given in the second parameter, at len. The output length will still be 51 characters, but the result will be justified to the value specified in at len. To have a result of the required length without trailing spaces, the UDF has to be enclosed in the left or sub_str function. Here are 3 basic examples, showing the 3 previous points, with a small positive and negative value. Notice that the UDF name has to be preceded with the owner, which is DBO. If a value with more than 38 digits is passed in, then an error occurs due to an arithmetic overflow. When the full 38 digits are used, the results occupy the entire length for negative numbers. If the value has more digits than can occupy the requested length, when one or more separators are added as required, an overflow is indicated by having an asterisk in all positions for the requested length. When fewer digits are possible, the result only needs to have a length to cater for the lowest and highest possible values, which is 7 for small int, 14 for integer, and 26 for big int. The unsigned 3 equivalents need 6 characters for small int, 13 for integer, and 26 for big int. Two tables have ID numbers as their primary keys. Determining the maximum integer and big int values for them, so that they can quickly be understood, needs to ensure that the maximum number of digits are taken into account, so that an overflow does not occur. A more intense calculation that does a sum of the ID values requires that the ID columns are converted to 38-digit numerics before calculating the sums, to avoid arithmetic overflows. Notice that the left and UDF functions are outside of the subselect that is performing the sum. Having them as part of the subselect is slightly less performant than when they are outside of it. Although this UDF is written to be as performant as possible, inserting 0 or more 1,000 separators into an integer that has been converted to a string takes more processing than just returning the value as a number. The drop in performance is because each row is processed individually. It is similar to the performance degradation that happens when a cursor is used to process one row at a time, instead of processing all rows with a single command. A table with a numeric 7 ID column, a big int booking ID column, and a char1 column containing a $sign in all but the first and last rows was created and populated. Four SQL files were created to time the extraction of the table's 5,643,216 rows and to time the summing of the booking ID column. The only differences between the 4 files were how the booking ID and the sum of the booking ID were output. Each SQL file was used as input to an ISQL connection in a Windows command shell, which was running on the same computer as ASE, to reduce any network latencies. The results were piped through findstr to discard all of the rows that were returned, except for the first and last rows. It took about 11.3 seconds to return all of the individual rows where no manipulation of the booking ID was done, with no manipulation of the sum taking about 1.3 seconds. Converting the booking ID to a string containing 51 characters and taking the leftmost 26 characters took about 12 seconds, with the sum taking about 1.3 seconds. With just the UDF used on the booking ID column, it took about 167.3 seconds, with the sum taking about 1.3 seconds. With left and the UDF used on the booking ID column, it took about 173.1 seconds, with the sum taking about 1.3 seconds. As can be seen, using the UDF for each row that is output has a dramatic effect on the processing speed. Consequently, it is recommended that the UDF be used sparingly, for example, just with totals calculated as part of a group by. Or use it in situations where its use for outputting a large number of rows can cope with a large increase in the elapsed time. The source for the UDF can be found alongside the link for this tips video, as can the input files used for the timing examples. That's it for this ASE-themed bite-sized tip. Thanks for watching. Bye folks.